Okay, so here is your notes for Unit 4.10. And yes, this is not the same thing as 4.1. This is not a decimal number. Um, so yeah, this is going to be a lesson on writing equations of quadratics given certain information about the graphs. So up until now, I've given you an equation, and then from that equation, you've worked with the actual equation to do different things, like graphing or solving and things like that. So now what's going to happen is I'm going to give you parts of a graph, very basic parts, so actual points on a graph of a parabola, and then from there, you're going to take that information and then write the equation that would match up with those points. So it's kind of working in reverse from what we've been doing. Three different situations here that I'm going to give you. The first one is I might give you guys the vertex, which is the highest to lowest point. And if I give you the vertex, then you only need one extra point. It can be any point on the graph. So it could be a point here, it could be a point basically anywhere. As long as you get a vertex and one extra point should be enough to give you the information you need to write an equation. So that's one instance of this type of problem. Another one is I could give you both of the not the vertex, both of the x-intercepts, and then any other point on the graph. And then from these three pieces of information, both intercepts and this one, you'll have enough information to make your equation. Or if I give you parts of this graph that have nothing to do with the intercept or vertex. So there could be any random 3 points. So let's say a point up here, a point over here, and a point over here. So none of those points is the vertex, and none of them are x-intercepts. It's just 3 random points. And then you got to figure out what is the equation of this. So I'll tell you right now, this first one and this second situation, these two are pretty easy. Pretty simple steps, doesn't take very long. This third one can take a little bit. So let's get into this. Use the equation matching the information. So depending on the information I give you, you're going to use one of the 3 various forms of quadratics that I've shown you in the past. So I might give you the vertex and any other point on the graph. So remember, the vertex is a point. So this is basically 2 points. One point of vertex, another point, doesn't matter, anywhere on the graph. Or I can give you both of your x-intercepts and then any other point on the graph. Or I can just give you 3 random points. Now, if I give you the vertex, right away you should be thinking about the form of a quadratic that includes a vertex, which is, surprisingly enough, the vertex form. Here's your vertex form. Y equals a times the quantity x minus h squared plus k. Now, if I give you the x-intercepts, I'll give you another point with that also. You will be using the intercept form of a quadratic, which is this one. Lastly, if you get 3 random points, you're not really going to have any of this information that you would need for these other 2 forms to work, so you would just go back to the standard form, which is this one. Keep in mind, any of these, you have to find a certain amount of information before you can start writing your equation out. So for example, this one you would need your a part, your h part, and your k part. So for example, let's say you found out that your a was a 6, so this would be a 6, and you found your h was a 2, so x minus 2 squared, and your k was a 5. And that would be your equation, because you found your a part, your h part, and your k part. So those are the numbers that you would have to plug in to actually get your equation out. Over here, you'd have to find your a part, the p part, and the q part. P and q are your x-intercepts. On the third part, you'd have to find the a, the b, and the c, and then you'd plug in those values. You'd leave the y and the x in there because you need those for your input and your output when you actually start graphing. But the parts that I underline are the parts that you need to actually find during with these type of problems. All right, so I did this one in class. I'll go ahead and do it again so you can follow. If you took the notes in class, you can just follow along with this. So I tell you the vertex and just some random point on the parabola. So the fact that I know the vertex automatically means that I should probably use the vertex form, which is y equals a x minus h squared plus k. Now, from the information that I gave you, you can actually figure out pieces here. So 4 and 1, that's just a random point. So I know that 4 is an x value and 1 is a y value. Now, 2, negative 3 is also a point, so you could put an x and a y up here, but keep in mind, we're trying to fill in as much of this as we can. So far, we got x and y. There's no reason why we'd need another x and y because I mean, we already got those two parts, so we should be looking at these other letters. Now, when you have a vertex, it's actually considered H and K. So if you know that specific point is a vertex, we actually call those points H and K because that's what that represents in this form. So now we have the Y, we have the X, we have the H, we have the K. Only thing we're missing now is the A, which is nice because if you look back here, we know the H and the K, we just need the A part. So we're just going to start filling in here. So your Y value is a 1. Your A value you don't know because there's no A's over here. Your X value is a 4, and your H value is a 2. Your K value is a -3. So right now, all I'm going to do is just plug all those numbers in. So your Y is a 1 equals A is just A, X is a 4, H is a 2, but it's a minus a 2, just minus H squared. And then your K is a -3, so plus a -3 is the same thing as a minus a 3. At this point, you would just solve for A. So just do some order of operations on this side to simplify the right-hand side of this equation. So 4 minus 2 is a 2. When you take that 2 and square it, you get a 4. So this whole part right here becomes a 4. So be careful though, don't do 4 minus 3. So right now what you have is A equals A times 4 minus 3. Now what I'll catch some students doing is they subtract this 4 from the 3. Now that's a very basic order of operations error. Before you subtract, you're supposed to multiply the 4 times the A. So you get 1 equals 4A minus 3. That's just a linear equation. So you're just solving for A, so you just do inverse operations. You would add 3 to get rid of the minus 3, and you would divide by 4 to get rid of the multiplying by 4. So it's just solving out from here, and you should get A equals 1. All right, so you have your A value. So you're going to plug your A value in here, so you get a 1. X and Y stay the same. A just becomes a 1, but when you have a 1 right there, you actually don't have to write it. H and K are right here, so basically I just plug in my A, my H, and my K, and I'm done. So keep the Y the same. X and Y should stay the same. Your A is a 1, but we don't have to write it because 1 times anything is the exact same thing. X minus H is a 2 squared plus your K, which is a -3, so minus 3, and that is vertex form. That is the equation of the parabola that goes through these 2 points. And that's all you need to do. Not too much work. Order of operation error is very common right here, so just make sure you don't make that error. Actually, it's right here with the 4 and the 3. All right. Example 2 is very similar to that. I'm not going to go over it though, just to kind of keep the time kind of lower. I'm just going to go over the ones that we went over in class. So x-intercepts. I gave you x-intercepts in an extra point. Since I know that I have x-intercepts, I should use the intercept form. So y equals a, x minus p, and x minus q. P and q stand for your x-intercepts. So let's go back over to the information. The information I have is a point, which are your x and your y, because there's no special letters that go along with that. Your intercepts are -2 and the 3. So this is your p and your q. It doesn't matter which one you call p or q. They are interchangeable, but basically it's like that. So I know my y, I know my x, I know my p, I know my q. So I'm just going to plug in all those numbers here for these letters, and the only one I'm missing really is this a part, so I'm going to solve for the a part again. And if you remember back here, I needed to find the p, the q, and the a. Right now I have the p and the q, so I'm just finding the a part, and then I'll be done. All right, so y is a 2. A, I don't know. X is a -1. P is a -2, but it's a minus -2, which is a +2. Times X minus Q, and Q is a 3. So minus, whoopsie. We know what X is. X is a -1. Q is a 3, so minus a 3. So we have A times this times this. So order of operation again, what we're going to do first is inside of the parentheses. So you're going to get a 2 equals A times a 1 times a -4. All right, so that'll be 2 equals -4A divided by -4. And you will get A is equal to -1/2. So you have your A, your P, and your Q. So Y equals A, which is -1/2, times X minus P, and then the P was a, what was P? It was up here. -2, so that turns into a +2, and then an x minus q, which is a 3, so it's minus a 3. That's how you do that one. All right, moving on to the more difficult ones. Example 4 was a very similar problem to example number 3, so feel free to try that one if you'd like. Example 5, that's only the third one we were actually doing in the class, but so with this one, I gave you 3 random points. I didn't tell you if it was a vertex, I didn't tell you if it was an x-intercept or anything like that. So here's your 3 random points. Now, what's going to happen here is that since I don't have a vertex, that means I don't have an h and a k. I don't have any x-intercepts, which means that I don't have any p's or q's. So I shouldn't use vertex form or intercept form. So the only form left for me to use is standard form. Now, with the standard form, though, it's a little bit strange. It's going to be a little strange here, because what's going to happen here is this. I have 1, 2, 3 points, and they're not h and k, they're not p's and q's. So the only thing I can really call them are x's and y's. Now, you have x's right here. You can't plug a 2, a 3, and a 0 in all at the same time for x's, because they are separate points. Same thing with a y. You only got one spot for your y here, and all 3 of them are y's. So what's going to happen is you're going to plug them in one at a time. First, I'm going to plug in a 2, negative 2 into this, and you'll get an equation. Then you'll plug a 3 and a 4 into this, and you'll get another equation that's different from the first one. And then you're going to plug a third one in and get another equation that's different from the first 2. So you'll technically have 3 equations with 3 variables left over. So let's do this first. So I'm going to put the points over here. So the first point is 2, negative 2. Okay, so that's that point. Now what I'm going to do is write my equation. So the equation is, so this is x and y. So the y value is a negative 2 equals a times your x squared. And we know what our x is. Our x is a 2 plus bx. And we know what our x is. Our x is a 2 plus a c. We don't know what the c is. We just know what x's and y's are. So all I did is I took my x and my y. I plugged it into the x's here, because there's 2 spots for x's and the y, and came up with this. Now, simplifying this out, I will get a negative 2. 2 squared is a 4, so we're going to get a 4a. So it equals a 4a. 2 times b is a 2b, plus a 2b, and then plus your c. So we have one new equation right here, which was this. Hold on. Yep, there you go. Now, I'm going to do the exact same thing with the next point, so 3, 4. So let me do this in another color. So 3, 4. So my y is a 4 equals a times 3 squared plus b times 3 plus a c. Simplifying that, I'll get a 4 equals a 3 squared is a 9, so I'm going to get a 9a. 3 times b is a 3b plus c. Now, hopefully this is starting to look kind of familiar. I have 2 equations so far with 3 variables. And if I have 3 variables, I need at least 3 equations to actually get an actual answer out. So this goes back to, I think it was last unit 3, where we had systems. This is going to be a 3 by 3 system, because we got a third point here. Now, luckily, this third point is actually kind of nice and neat. It's 0, negative 2. And you'll see why this is nice and neat right now. So y is a negative 2. A times something squared plus b times your x plus your c. We're going to simplify it. So what's going inside of here is your x values, which is a 0 and another 0. Now the reason why I said it's nice that we have a 0, 2 is because 0 squared is 0, and then 0 times a is 0. So this entire term right here is gone. Same thing here, b times 0 is 0, so that's gone also. Because when you add 0, this identity, additive identity is going to be the same thing. So this is gone, you just got c. So for this third equation, you know negative 2 is equal to c. Now, luckily, we didn't have a completed third equation, because otherwise we'd have to do the entire process, which takes a little while. And you will have to do that. But for now, we have these three equations. What I can do right now is, since I know c is equal to -2, I can plug the c value into here and here. So let's go ahead and do that. So right now I'm taking this, oops, I'm taking this and putting in for c right there and c right there. So I'm going to get a -2 equals 4a plus 2b and then minus a 2. 4 equals 9a plus 3b and then minus a 2. And let me move this over. Okay. Now what I'm going to do is, on both equations, I'm going to add 2 to both sides. So plus 2 here, plus 2 over here, plus 2 here, plus 2 over here. That way they're in kind of standard form. That way it's easier, more familiar to work with. So that'll give me a, what's that, 0 equals 4a plus 2b, and 6 equals 9a plus 3b. All right, so now what I'm going to do is just solve this by elimination, linear combinations. Doesn't matter which one you get rid of, so I'll focus in on the b's. So I'm going to make those opposites. So I'm going to multiply the top by a 3, bottom by a 2. And one of them should be a negative. So there you go. So the top by a 3 will be a 0 equals 12a plus 6b. Bottom is going to be a -12 equals -18a minus 6b. Your b's are now gone. You get -12 equals -6a. That means your a is equal to a 2. So I know 2 of them so far. I know my a value and my c value. Last one I got to find is my b value. So all I'm going to do is I'm going to take this 2 and plug it back into either these two or these two. Doesn't matter which ones, or even these two right here would work out. So can't really go too wrong with this, where you pick to put it. I'm going to pick this equation right here because it looks pretty easy, 4a plus 2b. So I'm going to plug it into 0 equals 4a plus 2b. I'm going to take this 2 and plug it into the a spot. So 0 equals 4 times 2 plus 2b. So it's going to be 8 plus 2b. Subtract 8 and then divide by 2. B equals -4. So final answer, y equals ax squared, and we found our a was a 2, so it's a 2x squared, plus bx, which is a -4, so it's a -4x, plus your c, and your c value was a -2, so -2. And that's standard form. Now, obviously, this will get more complex if this third one was not just a nice, neat 0, because then you're going to have the triple. In which case you should go back in your notes and then try to figure out how to do that one. I'll go ahead and start this up though with one that's similar to that, just to show you in case you forgot. So if you understand it by now, you don't have to watch this last example. But this last example doesn't have a 0 for the x, so this will be a more lengthy process. So let's go and get it started. I won't be as organized here. Y equals ax squared plus bx plus c. So first thing is I'm going to plug in this point. So that's my x and my y. So my y is a 7 equals a times x squared plus b times x plus a c. Then your x value is a 1. Second point, y is a -2 equals ax squared plus bx plus a c. And then your x is a 4. And last one, 5 -1. That's going to be -1 equals ax squared plus bx plus c. B's ugly. All right, now I'm going to stop and double check because I don't want to get too far with a mistake, because then I did a whole bunch of stuff for nothing. So my y's are 7, -2, -1, 7, -2, -1. First x's are 1s, second x's are 4s, third x's are 5s. All right, so let's go ahead and clean this up a little bit. So all of these will turn into 7 equals 1 squared is a 1, so that's just mean A plus B plus C. Second one is a negative 2 equals 16A plus 4B plus C. Last one is a negative 1 equals 25A plus 5B plus C. And that was the bell, so let me pause this for a little bit. All right, so now what we're going to do is we'll go ahead and, well, I'm going to go ahead and write these again down here. I don't feel like rewriting the whole thing again. All right, so I'm just taking these three equations. Now, if you remember how we're supposed to do this is that we're supposed to pick one of the letters to cancel out. Now, it's looking like the C's are a good candidate. So what I want to focus on right now is getting rid of all the C parts. So I got to combine two of the equations at a time to make them cancel. So first I'll do these top two. Now, you don't got to do much. But the C's right now, if I combine the top two equations, they're not going to cancel out. They'll get a 2C. I need it to be one of them's a negative C, one of them's a positive C. So I'm going to multiply the top one by a 1. And I'll multiply the bottom one by a negative 1. So you'll just get a 7 equals A plus B plus C. Then a 2 equals negative 16A minus 4B minus a C. Okay, so we're going to combine these. C's are going to cancel. So you get a 9 equals negative 15A minus 3B. All right. All right. So this one will be one of our new equations because we're trying to build a 2 by 2 system. So far I combined the first and the second one. So the other two I'm going to combine. Let's do the top and bottom. Wait, nope. Let's do the second and third ones. Let's see here. Now, same thing here. What I want to do is multiply. So if I want to combine, so let me write this out. So first I combine these two. Next up, what I'm going to do is I'm going to combine these two together. So with the green one that I just indicated, I have both positive C's again, so I want to multiply one of them by a negative. I'll go and pick the top one because I already did that one by a negative, so I know what's going to come up. And the bottom one will stay the same. So I'm going to rewrite this in green. So the top one, if I multiply it by a negative 1, is going to be a positive 2 equals negative 16A minus 4B minus a C. And then on the bottom is going to stay the same. Negative 1 equals 25A plus 5B plus C. All right, so now these two are gone. So I get a 1 equals, come down some, that's going to be a positive 9. Is that right? 9, 25. Yeah, so 9. A, and then B plus B. So this is our other one. 5. Yeah, okay. So we have this one and this one. That's our 2 by 2 system. So let's use those and actually solve. So let me section this off some. So I'm going to take, let's see here, 9 equals negative 15A minus 3B. Make 1 equals 9A plus B. So I'm going to focus in on my B part. I want to multiply the top by a 1 and the bottom by a 3. So I'll get a 9 equals negative 15A minus 3B. 3 equals 27A plus 3B. I can combine those, extend this page more. 9 plus 3 is a 12. What's that? Another 12. Is that positive? Yep, positive 12. And the b's will cancel. So I get A equals 1. So got my first part. Now what I'm going to do is I'm going to take that, plug it back in to one of these. Doesn't matter which one. So let's do 3 equals 27a plus 3b. I just took this one. And then now I'm going to put the a in there. So 3 equals 27 times 1 plus 3b. Let's see here. So now I'm going to subtract. Oh wait, 3 equals 27 plus 3b minus 27 minus 27. That's going to be 24 negative equals 3b. So b equals a negative 8. All right, and my phone's ringing. So now we have a is 1, b is negative 8. We're just missing our c part. So we're going to take this a and b and plug it back into any of the original ones. Probably the easiest one is this one right here. So let me take that one. Put it down here. So now what I'm going to do is take those and plug them in there. So a is a 1, b is a negative 8. So 7 equals 1 minus 8 plus c ends up being 7 equals negative 7 plus c. So c is equal to a 14. I believe that's right. A is a 1, b is a negative 8. So if all my computations are right, and as many of you know, with this many computations, it's very easy to make small mistakes. So if you spot it, let me know and I'll give you extra credit. But basically your answer, whoops, you don't have to write it like this because we're actually using them. So what we're using it for is our actual equation. So y equals ax squared. A was a. A was a 1, so that's just going to be x squared, plus bx, so it's minus 8x, plus c, so plus 14, and that's it. Okay, so much longer than the other one. Other one, you just had the zeros, just plugged them in. So on your homework assignment, I gave you 4.10 worksheet numbers 1 through 27. 19, 21, and 23 all have this 0 on, and then 25 and 27 both have the triples. So what I'll let you guys do, I'll let you go ahead and skip number 27. We'll make it 1 through 25 odd. Now, I do realize that's only one problem, but keep in mind that one problem is this type of problem. So I just kind of knocked this off of your plate. Okay, so just 1 through 25 odd on the homework, not 27. Okay, and have it ready by tomorrow. So, bye-bye.